Okay, section 7.3 Trigonometric Substitution. Okay. An integral that contains terms of the form like this can sometimes be evaluated by considering a new variable representing an angle which may eliminate the square root function. So this is the key. So when we do the integration, if we do not have a square root, it will be much easier to find the integral. So how we can do that? We can use the table of trigonometric substitutions. Like this, if we substitute x as a sine theta with this interval, then with this substitution, we can throw away the square root. In this case, if we substitute x is equal to a tangent theta, then after the substitution, we will not have the square root. Here, x equal to a cosecant square of theta in each of these integrals because of this. Okay? Like you see. And also, sine square theta can be written in this way, and cosine square are written in this way, as we see before. Find the integral square root of 16 minus x square over x square dx. X square over square root of 16 minus x square dx. Here, as we suggested here, square root of a square minus x square, let x be the 4 sine theta. Then, with this interval, then dx can be written in this way. So, square root of 16 minus x square is just for cosine theta in these angles. Okay? Because cosine theta is non-negative, we can throw it away. Then, integral of this one can be rewritten in this way, which is this, and which is this, because of this. And then, this is then this can be easily found as this. And for this one, do the same thing with x is equal to a sine theta, as we suggested with this interval. In this interval, this can be written in this way. So original function can be written as a cosine theta in this interval. So we do the integration in that interval to find this. Okay. After that, we may find the theta as arcsine x over a and cosine theta as. So we isolate theta and then replace it, those thetas and sine thetas in here to have this. This doesn't have any thetas in it after those least substitution. So as you see, this is a very nice looking integrations, and also the integration can be done with the very easy integrals that we already know. But at the end, the forms are rather complicated. For this type of integrals, and we want to do the square, completing the square on the square root. So we like to, if we have a form like this, then you do completing the square first, then substitute the x as equal to, u is equal to x plus 2. So change this problem with like this. Then do the substitution that we did before. Okay? Let u be the 3 sine theta. So you do the integrations like this. Then we substitute u and we substitute x to get the answers. But as you see, these integrals can be done like this. Integral of square root of a square minus x square x, which can be like this. this is exactly same as what you found in here, isn't it? This is exactly what you have. 9 over 2 and sine, arc sine x plus 2 over 3 and the square root of etc. etc. Integral square root of 4 plus x squared. Here we need to use the tangent theta substitution with this angle. And then square root of x squared plus 4 can be written as 2 secant theta, which gives us this integral secant theta d theta, like this. Then we substitute it to get what you like to have. Okay. So from here, so now you have this one. So in order to back to the function in terms of x, so we draw the graph of the right triangle with tangent theta is equal to x over 2. Then we substitute it the secant x and tangent x, which gives us this. And for this, such a case like this, we do the same thing. A times tangent theta as x, to have this integral to be this simple integral that we covered in the earlier section to get the answers like this. For this, as you see, x squared minus 16, so we naturally think x is equal to 4 secant theta in this interval, and then this integral, this square root can be simplified in this way, so this original integral can be written in this way, which is a rather easier computation. But in order to do the integration of square like this, then you need to use the double angle formula like this, and then you can use the integration technique for the sine, just the simple trigonometric functions with the chain rules. Right triangles with this allows you to find the theta and the cosine theta and sine theta. So after the substitution, you have this as the answer of it. Evaluate the integral of using the trigonometric function like the substitution like this, then that exhibits the cosecant t. Then this original integral can be simplified in this way. Then integration part works very well on it to give you this. This also can be done with the Sage, which gives, here you see the integral of this one is minus arc sine 1 over x, and that can be easily obtained in here. And as what? Minus arc sine 1 over x. That's exactly what you saw in here. Minus arc sine 1 over x. So after you do it, then you can go a little easier. Here, this is the other techniques which you better know. When you need tangent x over 2, let t be the tangent x over 2, then tangent of x can be written as 2t over 1 minus t square. Sine x can be written as 2t over 1 plus t square. Cosine x can be written as 1 minus t square over 1 plus t square. This kind of substitution can be used on the integration like this. Reciprocal of trigonometric functions. You can use it in this way. You can, those substitution, only this substitution will make this reciprocal of trigonometric functions much simpler, like this. Then you can use the techniques that you have learned before, or formulas that you have listed already. Or you just do the integration with Sage. Then you may have the same answers like what you have here. This is other representation of these equations. The others are the problems on integration of trigonometric functions with the various trigonometric substitutions. Okay, here most of problems are already solved, and so you may just go through it once before and find out some interesting thing. If you have any questions, raise your questions in Q&A so we can discuss while you are solving those problems. I think that's it. That's the end of today's class. Okay. Any questions?